Hey guys, welcome. One more class. In this class we will present the crystal, the personal crystal. It's here, you can see the component is here, crystal. The nomenclature on the board is here. It's the X6. Okay guys, in this case the X6, but the nomenclature on the board is letter X. This one is X6, indicating that it has at least 6 crystals of this type. Here on the board, you can see above here X6 to 7s or megahertz. To measure it personally, it has to be measured with the frequency meter, and how really our class and our course is not aimed at the frequency meter instrument. Simply the measurement on the multimeter, so that be a practical class, and since this is a component that rarely presents, give a problem in the crystal, so it is not our object of study. Always measure it with the frequency meter, but I'm going to measure it with the multimeter, with the board turned on. So I can know that it's already a test, more than enough for us to know if this component is working or not, okay? But there are already some signs that it is easy to know if he will come or not the problem. And why is he very important on the electronic board? Because the quartz crystal, it is widely used in oscillator circuits due to the precision of its personal natural frequency, so that's why it is used so much. How to test? We tested it with the frequency meter with the board turned off. To be able to give this value, in this case the X6, it has to give 27 megahertz. Okay people, and when does he have a problem? Normally it will present problem when voltages, the main ones, are having ungoverned variations. That is, it is very rare to actually have a problem with the crystal. However, when you measure principal voltages, what are they? 19 volts, 3 volts, 5 volts. Okay people, if these voltages have varying voltages, i.e. 18, 17, 15 volts, 3, 2, 1, 5, 6, 7, anyway, if these voltages are changing, probably a crystal has a problem. Okay, so this is a very interesting feature. But obviously you have the amount of megahertz. That this really makes us very attentive to know what it is, and his nomenclature. Usually it is X or Y on the board, and some very special observations I make about this component is the following. Normally on the notebook motherboard, we will find the frequencies of 14, 25, 24, 27, anyway, if it has a problem, you have to replace it with the same component, okay? The staff has to be the same, it has to be identical, okay? Then, you have to observe here on the component's body, and especially know how many megahertz this crystal has to exchange exactly for the same crystal. Remembering that 3 decay crystals, they serve as the time clock to start the motherboard. So if you have tension, if you have everything, observe the crystal. See if this 32 knots crystal is really showing a problem and is not breaking on the motherboard. Another one for K crystal tip. It will serve as an IC signal generator for the PWM frequency. Okay, and to 5K crystal, it will control sound and network. So even if you have problems with these components, you can go straight to it. You will already reach your goal. That is, there was a problem with the sound and the network. Did you check all the components around, not having any problems? Take a look at the To5K crystal that is controlling the sound and the network, and it will inform you. I already told you that the 3 decay one, and I'll show you that the X2 has 3 decay, okay? So if the X2 has 30 decay, it controls what it will control, the time clock to start the board mother. So it is always worth an obvious measurement to be able to see if he is presenting this or not this frequency. But using the frequency meter, if you have voltage on the board, observe, really if it is showing voltage in the component, which is already enough for you to know if it whether or not it's working, is a big indication. So let's go. How are we going to test? With the multimeter on the 20 volt scale, it should show different voltages on both sides. Normally, okay guys, but let's go to the tests, okay? I'm going to feed here on the 20 volt scale. Okay guys, I'm going there, I'm going to turn on the board. Perfect. Board on, black LED multimeter people here on board ground. So it's here, okay? I already have a black tip on the ground, a red tip on one side. Guys, it's here, 1.44 volts, okay? Red tip on the other side, 1.56. I.e. different voltages, however nearby voltages. Okay people, but different voltages, which is already a great indication that it is working. All the part of the symbol in the electronic schematic is also found in the handout, as well as all these tips I told you. Okay guys, so you can go to the next class, where we're going to talk about the transistor.